Welcome back to my channel Bal Vigyan Bharti. This channel is made for class 6 to 12 students. This channel will cover maths and physics for those standards. So with that note, I will start the chapter that I am just ongoing, that is vector addition, and simultaneously it will cover the subtraction also. Theory part, the addition laws we have already studied, and we have reached the problem solving up to 12 number of problem solving. Then further I will bring more solution, problem and solution. And now today we'll start with number 13. So number 13 says, if vector A plus vector V is equal to vector C, and the mod or the magnitude of vector A is equal to vector V, and that is equal to vector C, that means the resultant. If A plus B is equal to C, that means C is the resultant of A plus B, and but magnitude wise C is same as A and B. Okay, then find angle between vector A and vector B. So this is my task to find. So if vector A and B is equal, means it is given that vector A B is equal to vector C. So from that we can write, if it must be following the parallelogram law, and from there we can say that this is A square plus B square plus 2AB cos of theta, as per the parallelogram law. This is the resultant for this. This is equal to C, because magnitude we are equalizing the magnitude. Okay, if vector A and vector B, so magnitude will be same. It will be followed by this formula, this is parallelogram law. Now squaring up both the sides, we'll get A square plus B square plus 2AB cos of theta, and as you know that this theta is the angle between the A and B from the parallelogram law. If you remember, this is, let's say, A, this is, let's say, B, this is theta. So this is the theta is coming here, the law itself, the parallelogram law, and the magnitude of A, B, C, that means A, B and C all are same. So you can put those all equal to, let's say, is a K, a common thing. So this will be K square, this will be K square plus 2K square. A and B are same, K into K, cos theta is equal to K square. So eliminating all K square, so it will become 2 plus 2, 2 because 2K square is cos theta is equal to 1. So from here we'll get what? 2 cos theta is equal to minus 1. From here 2 cos theta is equal to minus 1 by 2, minus 1, and cos theta is equal to minus 1 by 2. Minus 1 by 2, that means cos of 120 degree. That will come to know when we'll do trigonometric problem on on some angle conversion, because what is that? Cos 60 is equal to half. That is a standard table, from there you can get. So cos 180 minus 60, that is equal to what? 2 into 90. Cos will be cos, as because in the second coordinate it will be cos 60 minus cos 60 minus cos 60 minus half. So what is that? 180 minus 60 means cos 120. So cos 120 is equal to half. So theta is equal to 120. So that angle between the A and B is 120. Okay. Okay, moving to problem number 14. 14. Two forces F1 and F2 acting at a point have resultant F. So there are two forces F1, F2, the resultant is F. If F2 is doubled, now condition comes, if F2 is doubled, F is also doubled. Means out of the two forces, if I double F2, the resultant F also will be doubled. Okay, then what is their relation? What is their relation? That means you have to find the relation between F1, F2 and F. Okay, fine. Now two forces F1 and F2 acting at a point having resultant of F. So you can assume that it is following some laws, whether it is a triangle, polygons, because it is three forces, so triangle or parallelogram we can think of. So parallelogram, if I think, then F1, F2 all together, if it is F, so it is F is equal to under root of F1 square plus F2 square plus 2 F1 F2 cos theta. Theta we are assuming the angle between F1 and F2. This information is not given, so we have to assume that it must be some angle acting with the theta angle F1 and F2. Okay, and F be the resultant of this. So squaring of this is squaring up will get F1 square F2 square plus 2 F1 F2 cos theta. So this will be our first equation. Now in the second equation it is saying that if F2 is doubled, so we can assume that F2 is doubled means is doubled in the same line, it is not changing its direction, so that angle between the F1 F2 will be same, but instead of F2 it will be 2F2 and this will be 2F. So the second equation will be similarly, if we square up it will become F square, F1 square will be F1 square, F2 square will be 4F2 square plus, if I keep F2 as 2F2, so it will be 4 F1 F2 and the theta will be cos theta. Okay, so now if I only replace, because this information is not given, so you have to eliminate cos theta from the first equation, so it will become 4F square F1 square plus 4F2 square plus 4F1 F2, and if I replace the cos theta value from here, it is F square minus F1 square minus F2 square and whole divided by 2 F1 F2. Okay, so I will write it freshly over. So ultimately 4F square is equal to F1 square plus 4F2 square, and you can see that bottom F1 F2 will be cancelled out, 2 will be cancelled out, so ultimately we will get 2 in bracket F square minus F1 square minus F2 square. So anything else? No. So you can rub it out. So the relation will become F1 square plus 4F2 square plus 2F2 square minus 2F1 square 2F2 square. So 2 will be multiplied with all those. So ultimately this f will go there, so it will become 2f square. F1 is 2 here, it is 1, 2, so 2f2 square and ultimately f1 square. So ultimately this is the relation. So what we can say, further we can reduce it to f2 square minus half of f1 square. So this is the ultimate relation between these forces as per the condition of the sum. Okay, so moving to next. Which of the following sets of forces, which of the following sets of forces acting simultaneously on a particle keep it in equilibrium, keep it in equilibrium. Okay, so there are options. Option 1 is 3, 5 and 10 Newton. The sets of value as given. Second set of value is 4, 5, 12 Newton. Third is 2, 6, 5 and fourth is, these are all Newton, and fourth is 5, 8, 1. So first thing is that to do that we need to have some understanding or concept to be clear, then after everything will be okay. Now you just read it out with me. Which of the following sets of forces acting simultaneously on a particle keep it in equilibrium? Now how to understand, if three forces acting on a point on a particle in different direction, these are in equilibrium only. We learned for the triangle law of vector addition, when three forces is represented by the three arm of a triangle and are in same direction, in same order or same direction. Okay, then the forces are said to be in equilibrium and A plus B plus C will be 0. That means the resultant will be 0. Okay, so there is no residue forces acting on that. So this problem may be represented or can come in different manner. Here it is said in equilibrium. Somewhere it may say that what are the set of value for which the particle will not be accelerated, because unless until there is a residue force in some direction, then there will be no motion for the particle, or if the particle is moving with a constant velocity, it will move on the same constant velocity even after it is coming under several forces, if the forces are being neutralized by them itself. There is no residue force or extra force exerted on the particle of the body. If a body is not exerted upon an extra force, it will not change its motion. The motion of a body which is in rest will be in rest, and which are in motion will move in a same velocity. It will not change its velocity or direction. Whatever you can say, it will not change its motion itself. So if the forces are equilibrium, there will be no acceleration. So that means it is same as the forces are in equilibrium. Okay, so these are the things that may become in that fashion, or it may say that yes, it's not accelerated, there is no residue forces, or like similar terms, no acceleration, no residue force, no residue. So all are of same category, no residue force. So if the problem is said in this manner, there are only one solution, one concept is there, that forces are following triangular law, and it is represented by the three arm of the triangle in same order, in same direction, in same order, you can say. So this force is starting with the point, at the end of this one force, the other force will start and end somewhere, and the closing side also will be in the same direction. Then you can say, so for a triangle, geometrically you can say the sum of two arm, means I am talking about the length, the sum of the length of two arm is always greater than the third arm. That we know from the geometry. Unless and until these two sides summed up is not more than the third side, it cannot create a triangle. It will be a straight line, because if the sum of is equal to the third arm, so it will be a straight line, it will overlap on that. Unless until there should some deviation of the value, it will not create any triangle. Okay, it cannot be lesser, it can be equal or more. If it is equal, then it will overlap on the third side. If it is more, it will be. So if you can take any two sides, if you add this two sides, it must be more than the third side. If you add this two sides, this also. So from that theory, that if we apply on this case also, if it is following the triangular geometry, that three vectors, so in that case, if you consider this set of values, you can see 3 plus 5, it is 8. Okay, but 8 is not more than the third side, so this is not possibility to be in equilibrium. Let me check another 3 plus 8. So other also you can check. If one is also failed, this is not less than 10. These other things will check. 5 plus 10, 15 is more than 3. It is okay. But one set is not following, so the full total set will fail, because out of the three means variation, if only one also fail, then that also will not follow the triangular law of vector addition or the vector laws. So they here 9 is less than 12, so this also doesn't follow. 2 plus 6, 8. So if I try the third one, 2 plus is 8, more than 5, the first set is over. 11 greater than 2, 7 greater than 6. So this all three combination is following the triangular law. Let me check this. 5 plus 8, 13 greater than 1. 8 plus 1, 9 greater than 5. 5 plus 1, 6 less than 8. So it is also not following. So only this thing is following the rule of triangle, and consequently the follow the rule of the equilibrium. That means if it is represented by the three arm of a triangle, then definitely it will be in equilibrium, and if it is following the triangular geometry, then this has to follow this rule. Any two sides adding would be more than the third side. So your answer will be the third one. Okay. So this is for now. The next video I will move on to number 16. Thank you.